Hey, what's up, guys? Welcome to Coding Bible. In the edition of this, creating machine learning algorithm for our movie regression data science project. We're going to be going over different machine learning algorithms, such as your linear regression and your regression methods, such as your reach and your lasso. Okay, guys, before going further, don't forget to like, subscribe, and turn on the notification bell to be first to be notified when I'm uploading data science and machine learning videos. Okay, guys, without further ado, let's head to business. Okay, the first step into our modeling video, we're going to be splitting our data sets into dependent and independent variables. Okay, splitting our data set. Okay, actually, guys, this video is a continuation of our previous video, which we created earlier, where we did the exploratory data analysis of our data set. These were the lines of code we wrote. These were the steps we went through. Okay, the aim of this our data science project is to build a dependable system. We're using machine learning in Python. This system will help movie producers, distributors, and investors make well-informed decisions regarding a movie's financial success. The ultimate objective is to maximize returns on investment in the film industry. Okay, so what is the problem statement we are solving in this our data science project? We are to use features such as your producer rating, marketing expense, production expense, and other rating to actually predict the outcome revenue or the return that will be generated by a particular movie. So that's the problem statement we're going to be solving in this our data science project. We have actually gone through the exploratory data analysis. I've actually gone through this already in various observations we made. I will place a link in the description below. So if I go check you out, and also I'll also place a link in the description below where you can download the notebook and also the data set for this project. Okay, let's actually head back to today's video. What we're going to be doing today, the modeling phase, splitting of our data set. We're going to be splitting our data set into dependent and independent variable. Okay, so our x is our independent variable, the df.work. I'm going to be dropping our dependent variable, which is collection. By the way, collection is same thing as the revenue that is generated by the movie, which is as is 1. And I'm going to define my y variable, which is my dependent variable, which is simply my collection. Okay, let me run this. What am I getting now? Okay, there's supposed to be an n here. Okay, so I've already splitted my variable. When I see my x now, I can see here this contains all the list of my independent variables. And when I check for my y, see it just contains one feature, which is my collection, a series, panda series, which is my collection. Okay, so the next step now, I'm going to be normalizing our data sets, our independent variable. Okay, I'm going to be scaling them. Okay, so to do that, I'm going to import sklen processing. I'm going to be importing our standard scalar. Okay, then I'm going to scalar. I'm going to initialize it. Standard scalar. Yes. Then transform our independent variable, which is our x. I'm going to simply call my scalar transform dot fit. Since it's a transformer, I'm going to use dot fit transform my x variable. Okay, and just quickly take a quick peek at my s cube. Okay, standard scalar is not defined. Okay, it should be an uppercase x. Okay, let me run this now. So here you can see my transform variable what this standard scaler simply do is that it scale our data set, okay? It places them in a close range in the sense that we don't want a case scenario where some of our value are in the zeros or maybe tens and other are in thousands or hundred. Okay. So to minimize this scale, you have to use this our standard scaler to scale our data set. Okay, because our machine learning algorithm actually love our data set to be scaled. Okay. So the next step now, we're going to be splitting our data set into train and test. Okay. Okay. Splitting our data set to train test. Okay. Then to do this, I'm going to be importing a library from sklearn. Model selection. I'm going to import train test split. Okay. Then I'm going to set my S. Again, S train S test Y train Y test. Okay. These are the variables that we store our S train, S test, our Y train, and our Y test variables. Okay. So then I'm going to call my test split. It's going to be accepting two major parameters, which is my S scaled independent variable, my dependent variable. Then I'm going to set my train size. Want to use 80% of our training set. Then I will set my test size. Okay. So 0.2, 20% for testing. Then the random state should be equal to 2. Okay. Let me just quick check my S train size shape. Okay. And my S test shape. Let me run this now. So here you can see our data set has been split. This is my train size. It contains 404 rows and 17 columns. And this is my test size, which is 20% of my data set. 102 rows and 17 columns. Okay. So I think we are done with this splitting of our data set. We have scaled our data set. Also, we have split it into train and test. Okay. So now we're going to be heading over to the algorithm. Okay. Since this is a regression problem, we are predicting the outcome revenue of a film industry when they produce a particular movie. Okay. So we are going to be using a regression algorithm since we are predicting on a continuous variable. So this is going to be linear. First algorithm we are going to be using linear regression. Okay. Linear regression. Over this to a markdown. Okay. Okay. To use our linear regression algorithm, I'm going to be importing it as sklearn also. sklearn is a very great data science package that contains a lot of machine learning algorithm. Okay. I'm going to say from linear model, I'm going to import linear regression. Okay. Let me run this. Then I'm going to name this our model 1. Linear regression. Moving initialize it. Then I'm going to call my model 1 dot fit. Both into a train and the train. Okay. Let me run this now. Okay. Here we can see our model has been trained and fitted on our S train and our Y train. So the next step now since our model has been trained, let's actually make predictions using this our linear regression model we just created. I mean, the main aim of actually creating these machine learning algorithms is able to make prediction on actual data. Okay, let's predict on our test data. I'm going to call this y pred equal to model 1 dot predict our test. Okay, let me run this. Then let me call my y pred. Okay. These are the predictions which our model made. Okay. Actually, this isn't that beautiful. I mean, you can just see how just a one-dimensional array that is scattered. So let me actually import pandas to data frame. We say pd dot data frame. Yeah, I would say it's to be actual. Okay, actual, which will be okay. My actual is going to be my white test. I want to just view the first thing, and my red predictions should be my y pred. Okay. Want first 15 or so. I think this should be it. Move on this now. So you can see our actual here, our actual prediction on our actual prediction from our y test and the predictions which our model predicted. You can see the difference. You can see here, wow, there's a lot of difference in this my column. This my 173. Our actual value was actual revenue generated by the movie was 7,000, and the predictions was 55,000. Yes, 55,000. And you can see here the prediction are quite close. This was 64,000 and this was 63,000. Okay, so to make this more visually appealing, let me actually use my matplotlib for mat. Okay, plot as plt. Okay, then I want to actually plot the actual and the predicted value on a line plot. Okay, to do that, I'm going to simply plot my plt figure and set the size to be 8 by 6. Then dot plot. Then I'm going to sorted my y test. Yes, I want it to be in an ascending order. I don't want it to be scattered. Then my label to be, this should be my actual values. It's actual values. Then convert my marker to time mode. Then same goes with the other one. Okay, sorted my y pred. Okay, and label is also and predict. Okay, predicted value. Yeah, so set marker to be the timer. Okay, then what to do next? Let me set my title. What is actual? This is predicted value. Okay, then let me give it a legend. So as we identify the color of the plot, then let me Roman plot. Okay, so here we have it. These are our predicted values and our actual value. You can see here. Let me actually zoom it out. Here you can see these are actual values. Our actual values is one on blue marker, and our predicted value is one on orange marker. You can see how close they kind of look like. You can see here at the start there are at least a little bit of difference between both of them, and as they keep going, we're getting closer, closer and closer. There were a large difference in this point, and I mean the greatest difference at this point. Our lastly predicted value have the greatest error to say, because actual value is highly greater than the predicted value. Okay, so we have actually used pandas data frame to actually visualize our predictions, and also line plot to actually visualize our prediction. But actually, this can actually give us right to say accuracy of our regression model predictions. Okay, so to actually do this, I'm going to be using a metric from sklearn called our score sklearn metric. I'm going to be importing our score to actually give me the right accuracy or the right overall accuracy of our regression model. Let me import it now. And let me set my our score, or it's going to be accepting just two parameter, which is my actual and my predicted. My y test, y. Wait, okay. Let me run this now. Here you can see we're having an accuracy of 59%. Wow, it's kind of low. It's kind of low. I mean, it's just a little percent above average. Okay, above 50%. So we do other things to actually improve this our model's accuracy. Okay. So the next machine learning algorithm we're going to be going over is our regularization method. Regularization method. Okay. Which, as we all know, is your reach and your last on this now. What we mark down on it. Okay. So this our regularization method isn't actually a machine learning algorithm, because I mean it was built upon the linear regression algorithm to actually reduce overfitting of our data set. Okay, it's mainly used when you want to reduce overfitting of a data set, or sometimes want to perform feature selection depending on the type of regularization method you are using, either rich or lasso. Okay, so to use our regularization method, we're going to be importing them from sklearn dot linear model, also from the linear model. Linear model, I'm going to be importing our reach, gate, and lasso. Okay, we run this or start. Oh, sorry, what's going on? To be a comma here. Okay, but what's this? I think maybe it's because this. Okay, I finally got it. Okay, so why both this reach and lasso work? Basically the same principle. There's actually different between this reach and lasso. Okay, this ridge actually is actually less sensitive in the sense that it doesn't actually reduce features that doesn't have high correlation with your dependent variable to actually be nothing or zero. Instead, it actually reduces their impact on the dependent variable, not actually taking it directly to zero. But this our lasso. This lasso actually, to some extent, actually reduce the independent variable will not have high correlation with the dependent variable to actually be zero, hence not contributing any significant contribution to the dependent variable. Okay, so that's just the major difference between your ridge and lasso. That's why most time you can also use your lasso as a feature selection method to actually select features that have high correlation with your dependent variable. Okay, the first one which we are going to be going over is our ridge. Okay, we are going to call this model 2. Go to our ridge. And notice it accepts just one major parameter, which is the alpha value. Okay, what alpha value are we going to use? The process of actually determining this alpha value is quite unknown. Just place value in it and hope it actually give you a gold score. Okay, let me run this. Then let me split it now. Model 2 dot bit s join I y join. Okay, and run this now. Okay, this is an alpha value of 10. Then let me actually make prediction with model. Okay, and so it's y squared should be equal to model 2 dot predict x. Okay, yes, okay. Then let me check the house score value of my house score of my y test and my y squared. Okay, which is the prediction I just made with our model 2, our ridge model. Let me check. Here you can see our model is still quite performing quite low, still 60%, just a little above my linear regression model. Okay, although I wasn't expecting that much, because I mean, this your ridge regression model actually function on this our linear regression model. So the next, what we're going to do next now, since we can actually tell the actual alpha value that will give us a very high accuracy, what we're going to use, we're going to be using what we call validation curve. Okay, we're going to be using validation curve to actually determine the best alpha parameter for this my alpha value. Okay, to use our validation curve, let me actually create more cells. Okay, so to use our validation curve, I'm going to be importing it from sklearn also. sklearn dot model selection. I'm going to import validation curve. Okay, validation curve. Oh, I think this should be an uppercase. We want this now. What's this? And you start. Yes, it's a lowercase. It's lowercase. Okay. So I'm also going to import no pay as np. This will help us generate a log space or an array of random values. Okay, this will help us generate array of random values. I'm going to call this param ranges, because literally we're actually creating a bunch of random value for our validation curve to actually tune our model based on this value and give us the best hyperparameter. Okay, so I'm going to use np to generate a random dimension array of values. np.log space. So we'll be needing, this will be -2 and we'll be needing 200 values. What this simply means is I want to generate the random value between 0.01 to 10 raised to the power of 3. Okay, 10 raised to the power of 2 to 10 raised to the power of 3. I want to generate 200 random values within this range. Okay, Let me run this now. Let me show you my parameters. Okay. Here you can see all our random values. Okay, let me just quickly delete this. Okay. Then the next step now, I'm going to actually pick them on my validation curve. Put experience scores, and test scores. Okay. Then I'm going to fix on my validation curve. Okay. Then I'm going to provide my algorithm or my estimator, which my validation curve is going to use, which is width. Then my S train and my Y train. Okay. Okay, let me zoom in. Okay. It is so much. Okay. My S train, my Y train, and okay. I'm also going to provide my param ranges. Param range. I'm going to set to my param ranges. I'm actually take this down. Then we'll set my param name, which is my alpha. Okay. So let me fit this now. Which is not defined. Okay. Wait. Okay. Let me run this now. So it's fitting. It's going to take quite some time because it's fitting on about 200 alpha values. Okay. 200 alpha values. Let me set my twin score. Sorry. Let me just my test score because that's the score which we are mostly interested in. We don't want to go about checking our twin scores. Okay. Scores. Let me check it now. So you can see here is simply a 5-dimensional array. So what our validation curve simply do is that it actually splits our data set into a 5-fold data set. As you can see here, we have a dimensional array of 5. Then it creates a model for each of these our fold of data set. Okay. So our first column may represent the accuracy for our first fold, the second one for our second fold, third one for our third fold, the fourth one for our first fold, and the fifth one for our fifth fold. Then the row here, we actually represent the accuracy that each of our upper parameter got. Okay. So that's just what this validation curve simply do. Okay. It's just a way of actually getting the best hyperparameter for your model. Okay. So how do we now get the actual value which we are going to be placing in our alpha value? Okay, to do that, I'm going to be getting the mean of this our range of value here. Okay, to do that, I'm going to say test call mean should be equal to my test scores. No, I'm going to say, let me say my np dot mean test scores. Okay, as is 1. Okay. Then call the param ranges we created earlier. Okay, the param ranges we created earlier. Param ranges. Okay, this is we created earlier. Then I'm going to use the index position, which is 128. To actually see where the position is. Okay, we can see here our best alpha value that gave us the highest accuracy score was at 16.446. Okay, this was the value, the alpha value we used in our validation curve to give us our highest test score. Okay, so let me now actually create and call this model series also my width, set my alpha to be 16.446. Okay, let me call model theory dot fit my training data. Okay, let me run this now. It has been fitted. Then let me make predictions with it. And wipe red because of my model theory dot predict predict my X test. Okay, let me check my white thread now. These are predictions made by my model theory. So let me actually get the arrow score. That's how we are going to really evaluate if really is performing better than the rest of our model. Arrow score Y test and my Y, but I just break it perform better than the rest. Let me see. Still 60%. Wow, it's kind of strange. It's 60%. Okay, just a little bit above my linear regression. They give me 59.9% accuracy. Okay, so what we suggest we do now. So this is going to be your task. I want you to actually use the lasso regularization method to actually fit on this data set again to actually see if it we actually improve on the accuracy we are getting now, which is 60.7. Okay, and when you are done, I want you to comment it on the comment section below. Okay, just actually change this my wish to lasso. Okay, that's just all you have to do. You guys, thanks for watching this video. Don't forget to like, subscribe, and turn on the notification bell so you'll always be the first to be notified when I upload new data science and machine learning videos. Okay guys, thanks for watching.